next class. This is the continuation class, class 3, about permutations and cyclic groups. Now, today I am discussing about cyclic permutation. Cyclic means repeated. Cyclic means repeated. Let us consider one set capital S is equal to A1, A2, so on, AN, and F be a permutation defined as, and F be a permutation defined as, ఎలా డిఫైన్ చేస్తామంటే దాన్ని F is equal to brackets open A1, A2, so on, AK, and then the next element AK plus 1, so on, AN. Now, the corresponding elements, that is images of these elements are, suppose let us assume that A2, A3, so on, A1. And the images are same, AK plus 1, so on, AN. Here we observe that the image of A1 is A2 and the image of A2 is A3 and the image of AK is A1, but the image of AK plus 1 is AK plus 1, AK plus 2 is AK plus 2, and so on. The image of AN is AN. Here some of the elements are permuted the same itself, that is AK plus 1, AK plus 1, AK plus 2, AK plus 2, and so on, AN, and so on, AN. That is f of A1 is equal to A2. The image of A1 is A2. F of A2 is equal to A3. So on, f of AK is equal to A1. And f of AK plus 1 is equal to AK plus 1. F of AK plus 2 is equal to AK plus 2. And so on. F of AN is equal to AN. This type of permutations are called cyclic permutations. This type of permutations are called cyclic permutations of length k of degree n. Of length k. ఎందుకంటే k అంటే ఎక్కడ దాకా అయితే రిపీట్ కావడం లేదు. Now this can be written as say brackets open. I will start with A1. The image of A1 is A2. So we can write A2. And similarly, the image of A2 is A3. The image of A1 is A2. The image of A2 is A3. A3 is A4. And so on. Last to AK minus 1. The is AK. And the next AK image is A1. Already A1 is repeated. We can stop. Enough. The remaining are permuted itself. So don't write. ఆ ఎలిమెంట్ కి అదే ఇమేజ్ వస్తుంది. అక్కడ నుంచి AK plus 1 దగ్గర నుంచి సేమ్ రిపీట్ అవుతుంది. కాబట్టి we don't write that one. Leave it. వదిలేసేయండి. So this is the permutation. This is the cyclic permutation. This is called a cyclic permutation of length k and degree n. ఎన్నైతే ఉన్నాయో డిగ్రీ సేమే ఉంటుంది. 20 ఉన్నా 30 ఉన్నా డిగ్రీ ఎంత అయితే ఉందో డిగ్రీ అంతే. రిపీట్ అయినాయి అని వదిలేసామని చెప్పి రాయము. ఎక్కడ దాకా అయితే సైక్లిక్ పర్ముటేషన్ రాశారో అక్కడ దాకా లెంత్ చూస్తారు. దిస్ ఈస్ ద సైక్లిక్ పర్ముటేషన్ ఆఫ్ లెంత్ k అండ్ డిగ్రీ n. కానీ n ఎలిమెంట్స్ ఉన్నాయి. కానీ cyclic of length ఎంత k. Understood? one example. Now, I will write the one example on cyclic permutation. Now, consider the set example. Consider the set S is equal to 1, 2, 3, 4, 5, 6, 7 and a permutation F and a permutation F on defined on S as F is equal to 1, 2, 3, 4, 5, 6, 7. The images are 1, 3, 4, 7, 5, 6, 2. Now, we have to find the cyclic permutation. Cyclic. What is the length of the cyclic permutation and what is the degree of the permutation? Listen. Similar, same one given, same element to same image on the కాబట్టి we don't write. Right? No need to write. Same element to same image ఉంటే no need to write. And we can start with the 2. The image of 2 is 3. The image of 3 is 4. The image of 4 is 7. And the image of 7 is 2. The image of 2 already వచ్చేసింది కాబట్టి stop. This is one cyclic permutation. And 1 కి 1 వచ్చేసింది, 2, 3, 4, 5 కి సేమ్ ఇమేజ్ ఉంది కాబట్టి no need to write. 6 కి సేమ్ ఇమేజ్ ఉంది, no need to write. This is the cyclic permutation. Therefore, F is a cyclic permutation of length 4 because here we observe 4 elements we get 1, 2, 3, 4 of length 4, but and the degree of F is degree is total how many elements? 7 and the degree is 7. Degree means the total number of elements in the given set, capital yes. But length is after finding the cyclic permutation, cyclic find out చేసిన తర్వాత ఎన్ని ఎలిమెంట్స్ అయితే ఉన్నాయో దాన్ని length of the permutation అంటారు. If length 4, length 5, length 6 and what else? Continuation. And one more example, consider the set one, two, three, four, five, six are defined as permutation 4, 5, 6. Here 3, 1, 4, 6, 5, 2. Now we have to find the cyclic permutation. We will start at 1 with 1 because the image of 1 is not same ga లేదు కాబట్టి we will start at with 1. The image of 1 is 3, the image of 3 is 4, the image of 4 is 6, the image of 6 is 2, the image of 2 is 1, that is repeated. No need to write. So close. 1, 2, 3, 4, 5 rala. But here the same image and same element. So no need to write 5 and 6. And we get all elements except 5. We get all elements except 5. So this is the cyclic permutation of length 1, 2, 3, 4, 5 of length. F is a cyclic permutation of length 5 and degree is 6. The total number of elements in the given set is called the degree of the permutation. Total ఎన్ని మనకి 6 ఉన్నాయి కాబట్టి degree 6 రాస్తుంది సరే. Suppose if the permutation of length 1, if the permutation is of length 1 కనుక అయితే that is called an identity permutation. Already we discussed in earlier classes what about identity permutation. Element same image 1 1 2 2 3 3 4 4 same element we get same images, that is called an identity permutation. The identity permutation of length is 1. If the length of the permutation is 2, if the length of the permutation is 2, that is called transposition. This is the very important definition. See, next definition, transposition of length 2. The permutation of length 2 is called transposition. Now, a cyclic transposition definition. A cyclic of length 2. A cyclic of length 2 is called a transposition. A cyclic of length 2 is called a transposition. For example, say F is equal to example A1 A2, here A2 A1. This is one of the permutation. We write the cyclic of length. First we have to find the cyclic permutation. We have to find the cyclic. You can start with A1. The image of A1 is A2. And the image A1, the image of A1 is A2. The image of A2 is A1. A1 is repeated. Therefore, F is a cyclic of length 2 because it contains 2 elements. So, cyclic of length 2 is called a transposition. I'll give you one more example. A second example. Say F is equal to 1, 2, 3, 4, 5. 1, 2, 4, 3, 5. That is equal to. You can start with 1. The image of 1 is same. No need to write. And we start with 2. Same. You can start the image of 3 is also 2. No need to write. I will start with 3. The image is different. So we can start with 3. The image of 3 is 4. The image of 4 is repeated 3 repeated 4 is 3. The image of 5 is 5. No need to write. Therefore, F is a cyclic of length 2. Is called a transposition. And the degree of the permutation is how much degree? 5. Because the set contains 5 elements. That is the degree of the permutation. Is it clear or not? So this is the definitions of transposition and cyclic permutation. Now I will give one more example, one more definition. Disjoint cycles. Disjoint means, one more definition. Disjoint cycles. Disjoint means disjoint, no joint. Disjoint means no common elements from both the sets. We can take two permutations or two sets. The two permutations does not contain the same elements. That is, the no common elements is called disjoint of cycles. For example, consider a set. Consider capital S is equal to A1, A2, so on, AN, and F comma G and F comma G are two permutations. Two permutations defined over S. Now, the cyclic of F comma G have no common elements. No common element from G and F. For example, S is equal to S is equal to 1, 2, 3, so on, 7. And we can take two permutations. F is equal to 2, 3, 4. G is equal to 1, 5, 6, 7. 1, 5, 6, 7. This is one permutation and that is another permutation. This permutation contains three elements. That is, the cyclic of length is 3. And G is another permutation of cyclic of length is 4. Because 1, 2, 3, 4. Cyclic of length 4 and cyclic of length 3. We observe here from these two permutations, no common, we observe no common element. We observe. Any common element is there? No. ఇక్కడ ఎక్కడైనా కామన్ ఎలిమెంట్స్ కనబడుతున్నాయా? లేదు. కాబట్టి therefore F comma G are disjoint cycles. ముందు పర్ముటేషన్స్ ఇస్తారు. పర్ముటేషన్ ఇచ్చిన తర్వాత వాటి యొక్క సైకిల్స్ కనుక్కోవాలి. సైకిల్స్ కనుక్కున్న ఫైండ్ అవుట్ చేసిన తర్వాత అప్పుడు డిస్జాయింటా కాదా అనేది మనం ఫైండ్ అవుట్ చేయాలి. క్లియర్? దిస్ ఇస్ ద డిస్జాయింట్ ఆఫ్ సైకిల్స్. ఓకేనా? అండ్ వన్ మోర్ ఎగ్జాంపుల్ 2, 3, 4. ఎగ్జాంపుల్ F is equal to 2, 3, 4 and G is equal to 1, 2, 4. Here we observe 2, 4 are repeated. No common elements and a condition failing. Why? 2 and 4 are repeated from both cycles. From both cycles, 2, 4 are repeated. These two are disjoint or not? Disjoint or not? These two are not disjoint because common elements ఉన్నాయి. Common elements ఉన్నాయి అంటే ఏమవుతుంది? That is not disjoint. Then it is clear. Okay na? Hence solve. Thank you and thank you.